Hi there. In the last video, we were looking at properties of definite integrals, and we looked at a whole bunch of them. In this video, we'll use those properties to solve a couple of problems. So we've been given some facts. We don't know what f of x is or g of x is, and we don't have a diagram for it, nor do we need it. The important thing to know is that these are given to us. So that the definite integral from 1 to 6 of f of x dx is 3, from 1 to 10 is 8, and for g of x, we've got from 1 to 6 is equal to 4, and from 6 to 10, it is 8. So these are our facts, and we need to make sense of those or use those facts in order to solve problems. So let's have a look at slide 6 there. Question 1, just find the definite integral between 6 and 10 of f of x dx. Now, you'll note that looking at slide 5 there is no integral which goes from 6 to 10. The only two facts we've got is the one that goes from 1 to 6 and the one that goes from 1 to 10. And we're only interested in from 6 to 10. So what do we know? Well, we can say that the integral between 6 to 10 is going to that of f of x dx is going to be equal to, well, we can use that rule which basically says we can split that integral into two integrals with a midpoint effectively. So what I might do is actually just go back a little step, because it's probably going to make more sense to do it this way without subtractions to start with. So I'm going to take the integral from 1 to 10, and the reason why I'm doing that is you can see that I've already got a result for that. And I'm going to split that integral from 1 to 6 f of x dx plus the integral from 6 to 10 of f of x dx, okay? So why do that? Well, it's all about planning ahead, isn't it? I know I've got 1 to 6, and I know I've got 1 to 10. And it's no coincidence that 6 to 10 is kind of like the missing link there. So my 1 to 10 is now split to 1 to 6 and then 6 to 10. Okay, this is good news because some of these I have values for. So the 1 to 10 I know is 8, so I can replace that with 8. The 1 to 6 is 3, I've got that. And the 10 to 6 is what I'm looking for. Like so. And now if I take 3 from both sides, I'll have what I was aiming for. So I've got the integral from 10 to 6 of f of x dx is equal to 5. Boom, done. So that's not too bad. This one here, well, it's a bit different, I guess. So that's why I've kept it in there as an example. And the thing is that we don't have g of x, we have g of x plus 2. And the reason why I like this question is because it gets you to think about the fundamental nature of what you're doing here. G is still g, but instead of inputting x, you're inputting x plus 2. So effectively, all of the values that you have been putting in are going to have 2 added to the input. So we're actually going to shift the whole function across, as you know, because it's basically a horizontal translation. Now, the point here is, what impact does that have on our boundaries? Well, effectively, the boundaries are going to shift by 2 units. And so I can say that the integral between -1 and 4 of g of x plus 2 is equal to the integral between -1 plus 2, which is 1, and 4 plus 2, which is 6, of g of x dx. And the good news is, we know what that is, it's equal to 4. So although it looks tricky, it's not too bad if you keep your wits about you and remember your fundamental understanding of functions and the idea of how transformations work. Okay, that's 2 quick examples. Have a go of doing some of them yourself, and I'll see you in the next video.